Good morning. My name is Saptajit Raha. I'm from class 9Y. Today I'm going to present a project on conic sections. So there are four kinds of conic sections. The first conic section is going to be the circle, which we can get by cutting the cone parallel to the base. You can see it here. Then we are going to get the ellipse, which we can get by cutting the conic at a certain angle to the base, as we can see here. Then we have the parabola, which we can get by cutting the cone at more than the slant angle. And last of all, we have the hyperbola, which we can get by cutting it parallel to the base. So we can also see each of the conic sections in the following image. Now we'll move on to some of the uses of conic sections. So the circles are used to navigate the location of the person. By taking the intersection of three circles, we can figure out the location of a person. So in a 3D world, we can also use this technique, but in 3D we have to also find out the altitude of the person. So in that case, we have to take the 4 satellites and we have to take the spheres, and then we have to take the intersection of all the 3 spheres. So now we'll move on to ellipses. So an ellipse is defined as the collection of points such that the sum of distances from the two focuses is going to remain a constant. We can also see the following in the following animation. So d2 plus d1 are the distances from the focuses. It is always going to remain a constant. And it has another property, is if we send one light ray through one focus, it will reflect onto the other focus. And similarly, a light ray to the other focus will reflect onto the first focus. Now this is also used in auditoriums, and we can also see ellipses in the orbits of planets and comets. Now we'll move on to hyperbolic navigation. So in hyperbolic navigation, we only know the differences of the distances of the 3 points from the treasure, and based on that we can graph two different hyperbolas, and the intersection of those hyperbolas will determine the location of the treasure. Now this is called hyperbolic navigation, and this technique was used in olden times to find the location of a person, and an example of this would be a Lorentz sea. Now we'll move on to parabolas. So the property of a parabola is that this is going to be the focus, and if a light ray is sent through the focus, it will be reflected parallel to the y-axis. Now if light rays are sent parallel to the y-axis, they will converge onto the focus. Now if we rotate this around, we can see that this same concept is going to be used in antennas. Well, a receiver is going to be kept on the focus, and when light rays are coming from satellites, they are going to be parallel to this receiver, and they will converge onto the focus where the receiver is kept, and the receiver will capture the signal. Similarly, when the receiver will send out signals, they will be sent parallel to the receiver. Now we can also see the use of parabolas in solar cookers. Now we are going to move on to a few other examples and the equations of each of these conic sections. So the first conic section we see about is going to be a circle. So a circle is going to be a collection of all points that are at a certain distance from a single point known as the center of the circle. The equation of a circle is x minus h square plus y minus k square is equal to r square, but h and k are going to be the center. H and k are going to be the coordinates of the circle, and r is going to be the radius. Then we'll move on to ellipses. And this is a plane curve such that the sum of the distances from the two focuses is always going to remain a constant. This is used in removing kidney stones and also in the shapes of orbits and of comets and planets. And hyperbola is a plane curve generated by a point such that the differences of the distances from the focuses is going to be a constant. This is used in nuclear cooling towers. Next up is a parabola. So a parabola is a U-shaped plane curve such that the distance from a fixed point known as the focus and a fixed line, which is the directrix, is always going to remain a constant. The equation of a parabola is y square is equal to 4ax. It can be seen in rainbows, trajectory of balls, antennas, solar cookers, and the part of rockets. Now we'll see some of the graphs. So green is going to be the graph of a circle, blue is going to be the graph of a ellipse, red Orange is a graph of a hyperbola and red is the graph of a parabola. Thank you.